Okay, so we talked about this graph. Make it nice and big a little bit. Yeah. Can't do this with a whiteboard. Okay, so we said two things about this. Thing one, the slope of v versus t is acceleration. Is that too, just sorry, size judgment, is that readable?
Yeah.
Okay. Slope of v versus t is acceleration. Two, area between the velocity graph and the time axis. And I'm just going to pause before I finish that. It's very tempting, and I often do say things like the area under the graph, but we don't necessarily just mean the area under the graph. We mean the area between this red line and the horizontal axis. So if the red line is below, we're talking about the area above the graph, but the area enclosed between these two things. Yes?
What does that say next to area?
B/T, so it's between, like, are those meaningful abbreviations to you? Like between, within, with respect to, because they're just, yeah.
I use W/O for without. So.
Yeah, they absolutely W/O for without. They're just, it's quickie shorthand. What's happening, Lieutenant?
All the wild excitement you can handle.
Oh.
It's all happening.
Woohoo!
Yes, sir.
Okay.
Physics, man. Doesn't get much better.
And so,
Unless you get stronger.
that's pretty awesome. And so this, hey, let's do this in steps. All right? Well, maybe there's a limit. Okay, how about this? Can I go over? Are we good? How about a little more? A little more, a little more? All right. So this leads us to, oh, I didn't finish the statement. I stopped and parenthesized without finishing. The area between the velocity graph and the time axis is equal to the displacement. Somebody remind me the difference between distance and displacement?
Distance is just like how far you go, like total, except displacement is like the start or the end point minus the start point.
Absolutely. End point minus the start point. So displacement is going to is basically any round tripping you go gets wiped out, and positive and negative is going to indicate direction. And so we start to develop some equations. And so our first equation might be the acceleration is the final velocity minus the initial velocity over the time. And then we came up with another one, which is that the displacement is equal to v initial plus v final divided by 2 quantity times the time. And in addition, I'm just going to point out this little thing, which is this. Maybe I'll do this. This first equation here, notice that it does not care about displacement. This equation here does not care about acceleration. You may sense that a pattern could come from this. And if you sense that, you are correct. If you don't sense that, it's worth thinking about. Nope. Undo. Undo. Boom. Oh, we'll undo. So let's go back to these equations. So here is what I would like you to do in a moment, and I'm going to give you a couple of people who I would like you to hang out with. And I would like you to hang out and talk about whether you can use these ideas and any other tools you like at your disposal to come up with some more equations that connect these things up. Okay? And I want you to, what I'd like you to do in a moment is I'd like you to sit down. I would like you to summarize for each other, like, I worked on this, I worked on that, and if you're like, I'm sorry, last night I was a conscientious objector from homework and instead I watched old episodes of the X-Files, feel free to be honest about that, right? This is not graded. And then I would just like you to please discuss, and I'd like you to get to the place not just where you're like, well, we have one more equation to share or two more equations to share, but where did they come from? Okay, where do these equations come from? So I'll ask you to talk about that amongst yourselves and see how much progress you can make in, say, 10 minutes, and then we'll come back together and talk a little bit. Okay? So, could we have Arjun Andrew Aaron, back table. Billy Tiernan Richard, that table right there. Brody, Hannah, Andy, that table right there. Maddie and Lainey, wherever you choose. You can find a place up here. You can be like, oh, we're so special, we're going to the hall. Whatever. All right, Maddie.
Yeah. Oh, wait, her roommate's name is Maddie.
Oh. Okay. All right. So here we are. We've got this basic idea, these two ways of working with it. We've come to these two conclusions so far. What I'd like to do is just go around from each group and just really briefly, just what did you talk about before we get into the nitty-gritty? So, Lainey and Maddie, what did you talk about? So you did like manipulate, like a substitution of one thing into another thing? Okay.
Some of them we ended up getting very simple, so we weren't sure.
Yeah, no, and sometimes like you do these substitutions and things kind of fall apart. It's like taking a piece of yarn and tying a knot, and then you pull and the knot comes out, and it's like, oh, what I did was, yeah. Okay. Cool. Aaron table from the back. What did you folks talk about?
So Aaron had an equation, goes like VF equals to VI plus AT, although it's just still substitution of like the first equation, but it makes perfect sense because the final speed is the initial speed plus the time times the constant acceleration, which makes sense. So that's what we're talking about.
Okay. Cool. Brody table. What did y'all talk about?
You were just trying to figure out how to like create an equation without doing like the substitution stuff,
Okay.
and we didn't come up with anything.
Okay. All right. Totally fine. And Kiernan and Richard and Tommy. Okay. All right. So, does any group have an equation that they think is new, like it's not algebraically identical to one of these things? It's not just a rearrangement of one of these things that you'd be willing to talk about what it is and where it came from?
Yeah. So.
Okay. Wait. So, I'm actually going to ask you to, if you don't mind, like you and like come up here and just like I'm going to make you some space over here, and you could do some explaining.
Okay, sure. It wasn't
Awesome.
actually my idea.
Well,
but,
you can
I'll
steal
take
it, or you
credit for it now.
can drag somebody up there. Drag, phone a friend.
So, Aaron, do you want to come up instead?
I don't know. The way I got it, I feel like I did it wrong to get it, but I just ended up.
Oh yeah, I mean, if you want, I can.
No, let's see what happens.
Alright.
This is for the purpose of conversation. So.
Sure. Okay. Alright, so basically, we had like the velocity time graph. So, yeah, so this would be like VI, and then VF, and then T. So it's just like pretty arbitrary, but we drew a line, and then that would be the acceleration. And then from there, you can kind of tell like the y based on like the slope equation. So it'd be like y equals mx plus b, and then in this case, the m is the acceleration, as you can see. So, and the y is the v of f. So the final velocity. So yeah, it would be acceleration times x and then plus b, and then the x is the t value here, so you could make that final velocity equals acceleration times time plus b, and then the b value is the initial velocity, so you can also substitute that. So final velocity equals acceleration times time plus the initial velocity.
Thoughts, comments, questions?
Isn't that just the first one rearranged?
Maybe.
Maybe. So one thing thank you. All right, one thing that I really like about this. So I'm just gonna highlight this. Oops. How about? Let's see if I can learn. That's a better highlighter, sort of. So yeah, is this the same thing as the other thing? Let's. Oops. No, hang on a minute. Undo. Boom. Is this the same? Is that the same? Can we manipulate this? So if we have v final equals acceleration times time plus v initial, is that the same? How do we decide whether this is identical?
I mean, you can just subtract the initial velocity and divide by time.
Okay, sure. it's mathematically identical. So I would call this the same equation, but I do think it's really worth looking at. So any one of the equations that we have, we can rearrange however you want. We could be like, oh, I have an equation for, final velocity, but now I'm going to turn it into an equation for acceleration. Totally legit. We haven't discovered anything new, but it's just a rearrangement. But what I like about this, and Andrew and I were just talking about this, is that, like, I think, and this is personal, like, I don't know about you, but for me, as I was learning math, and I guess it's probably still true, like, the first time I started learning some piece of math, if I looked at an equation, it just looked like a bunch of symbols. And like I could learn some rules to move the symbols around, but it felt kind of like a game. And then as time went by, looking at equations started to have meaning, started to tell a story. And that I usually feel like, oh, I really understand this particular piece of math when looking at an equation starts to have meaning, starts to feel like, oh, this tells me a story. When I look at this starts to tell me a story. It's like, oh, how fast was a thing going after a certain amount of time had gone by? Well, how fast was it going originally? And then we add some to that. How much do we add? Well, it's like, how long did it run for times how much was it speeding up or slowing down? And so this sort of feels, like the other one feels like, let me tell you what is acceleration, and this is kind of like a story about, but it's still basically the same thing. I'm going to put it on our list, but it's kind of in the category of like, oh, I'm the same thing. So I'm just going to go like, can I go in here? No? Yes? Yes. So now I'm going to be like, oh, hey, by the way, this is the same thing as, V final equals V initial plus AT, right? This is just a part of that. Awesome. Does anybody else have something they talked about that they'd be willing to or interested in discussing? Please? Yeah, absolutely. And if you're showing us something, feel free to drag your partners in, or make them come up and help you, or answer questions.
Like that one. Yeah, so basically it's another variation.
Oh, hang on a second. You're gonna have to see at the bottom. See this little pen thing. You're gonna have to tap the little that guy. Now you're good. You might want to change it away from it.
Yeah. So as we know, we have acceleration equals to change of velocity over time, and then we also have displacement equals to the average speed times time. So because we try to connect them together, so I try to substitute this t using this equation, so we would have d equals to so here t is actually equal to the change in speed over acceleration. So by substituting that, we will have the average speed times it's still time, but now we get to express it using a, then with the, don't know how to call it, equations.
Difference of two squares.
Yeah. We would have vi squared, vf squared minus vi squared over 2a. At first I thought it didn't really make sense because it's just like a math equation, but then when you actually think about it, it's still the average speed times the time. it changes its mathematical expression, but the like internal meaning is still is still the same. Yeah. So
Thoughts, questions, complaints, praise.
I did actually have a similar line of thinking.
Yeah.
To you, Andrew. Like, I basically did the same thing. Like, oh, I can rearrange the acceleration graph to make it where the acceleration equation to have it equal to time, and then replace the t for the displacement equation. And I think I kind of like had like I tried to like do something, but then I kind of like I thought like what I got was like more like I kind of re-examined it, was like, oh, I think I just multiplied wrong.
Did
So
you end up in the same place or someplace different?
I ended up in some place like different, but only just because like I forgot how to multiply.
Oh, you think maybe it was an algebra mistake?
Yeah.
Okay, all right, awesome. Tune, do you want to add something?
Thanks for Andrew, because me and Richard had the same thing, but we just arranged ours a little differently.
Uh-huh.
So we took the same equation, but it was equal to VL squared instead of D. But same equation.
Right, yeah, and you can write this in lots of ways. I mean, this sometimes gets written as 2AD equals V final squared minus V initial squared. This can be written in all manner of ways. It's the same thing. So, can we agree that this is a new thing? Okay, so let's put our new thing in here. Oops. Wait, I don't know if I have a. Do I have a tool for this? Can I move this stuff somehow? Yes, that's good. That wasn't beautiful. This is, I just
Did
learned
you
this.
almost just try and go like that?
Well, no. Ready? Ready? Oh, I wrote here. Oh, it doesn't work in this one. Sorry. One of the apps on this thing, if you put your palm on it, it understands that it's no longer a point and that you're trying to erase. Like, there's one of the apps on here, and I was doing that today, and I was like, "That's brilliant. That makes me so happy."
So, side note, how do you get your like Mac to connect to one of these?
That's something I've been working on for months, and I just figured it out.
Because
So
we tried to do it last night, and because we were in.
I can show you after class.
Okay.
Yeah, you actually have to download a piece of software, but it's free.
Okay.
Yeah, I'm really hoping that we'll start to get to the place where, like, if once students know how to use these in a sophisticated way, that we'll all get more sophisticated about how to use these. Okay, so I'm going to add this to our list of equations here, and I'm going to put it the way, Andrew, you put it as a D equals. Okay, I'm going to put this as a D equals V final squared minus V initial squared over 2A. Oops. And then I'm going to editorialize in the same way that I have editorialized before. What is not in here? No time. No time. No time. Okay. No time. No time. Sorry. No time. Wow. How did this end up so big? Who knows? Doesn't matter. It's an infinite whiteboard. We're not going to run out of whiteboard. Well, we seem to have run out of whiteboard. Really? You're really not going to let me go any farther down? Well, I guess it's not an infinite whiteboard. We have run out of whiteboard. This is what happens when you waste whiteboard, people. You get to the edge of the whiteboard. This is not a sustainable situation.
Well, you could just zoom in, so your writing's actually small.
This is why I work with students, is they have smart ideas. Oh, but now I'm stuck again.
think you have to expand it like on one of the tools on the bottom.
Is there maybe the plus?
I think the plus makes a whole nother one. It's like other stuff.
Or what about the 3 lines on the top right?
Okay, wait, I don't think this is important. Let's talk about physics. I do love to play with the technology, but we have things we gotta do. So, anybody else have any other places they ended up? Yeah?
We did the same thing, but just for acceleration.
Did you end up with a different equation at the end?
Yeah.
You did? Yay! Talk to us.
Okay, so we did the same thing that they did for displacement. We just did it with the acceleration one. So I don't know how to like.
It's okay if people can't see what you're writing while you're writing it, because you're going to be able to step away. Plus, it's all being recorded on video later.
Okay. Okay, so we had these two equations, and then what we wanted to do is we substituted this. So we solved for this for
Something's
t.
wrong.
What?
Second equation is wrong.
Plus.
Oh, sorry. So we solve this for t. So you'd have d divided by bf. Sorry, I messed up the v a little bit, but and then we substituted this into the t. So then you have vf minus. And then divided by and then we just kept going. Does this make sense so far?
Is that a minus sign or an equal sign there? The fraction.
This?
Yeah, that.
That says divided by.
Oh, okay. I couldn't see the dots.
Yeah. But when we did this, I'm just realizing that we didn't use the 2, so we just had the d over vf plus vi. So I don't know if it'll turn out different.
Right. Yeah. If you just brought the VF minus VI and you didn't bring the 2 along with you,
Yeah.
then I think we broke. I think it broke.
Yeah.
Although of course it would just be
You bring along the 2. I think if you bring along the 2, I think we're going to end up in the place that we just ended up above. Oh no, because
They don't use any.
oh, they don't use A. You're right. They don't use A.
Yeah.
Well, I think we already have an equation without A.
No, we do.
I think part of why I'm confused is like, where's your equal sign? Like, we have stopped having an equation. You know what I'm saying?
Sorry.
Ah, now what do we not have? We have everything. It's a tutti frutti o Rudy. I guess I don't get this because, like, is that an equation right there? Right, this thing right here, is that legit? That's legit physics. I don't think we can then take this equation, and only do something to the right-hand side of it and not to the left-hand side. You know what I'm saying?
Wait, Lainey, why do you still have
I don't know-
T
yeah.
if you're
Yeah, that's what I'm. Oh, yeah. Okay.
So I think
We're going to end up with an equation that doesn't have t, which is going to be like this. Okay? I like the direction you're going. And I think basically what you did was you came up with another way of getting there. I think we could do out the algebra here, and that's where we would end up. Yeah, because you're going to go this divided by this fraction. So when you divide by the fraction, we're going to flip this upside down. So we're going to have the VF minus VI times the VF plus VI, which is that difference of two squares thing.
Yeah.
Awesome. Cool. Another route to that. Another route to that. Richard, do you have something that ends up in a different place?
A very weird one, actually.
Let's say.
A very interesting one.
Okay. Like interesting?
It's the speed when you reach the halfway.
Show me.
Over. So let's see this one.
What's on the left?
It's 2 over at the end. So the halfway.
So this is also a thing without acceleration, right? I think this ends up being identical to, like, for reasons I'm not going to try to justify myself here, but to go back to this. Once we're here, really what would be awesome to have is, like, we would want, first of all, let me ask this. How many more equations do you think are floating around out there?
2.
And what would the characteristics of those equations be?
No VF and no VI.
One, we're looking for something that doesn't have a VF and something that doesn't have a VI. Do you end up with
I
one
think
of
I have one without VF. But I don't know
We
if
got one that
I
does
simplified
not.
it all the way.
Oh wait, no, we didn't.
Let me get you some space here.
I just substituted it again, but for VF instead.
Okay. There's the stylus, and then you have to hit the pen
Okay.
thing. There you go.
So I took the first one, which is and then I multiplied the t, so it's AT equals VF minus VI, and then I added VI. And then now that you have VF alone, you can substitute this for VF in a different equation. So I took the one that we just made a second ago without t, and then I did. Oh, I just realized something was wrong, but I think it might still work.
You're about to start writing in rainbow because you're
Oh.
It's okay. I mean, it's beautiful. I think go for it.
Yeah, I'll go for it.
Yeah, go for it. And can you draw a unicorn too, please, when you do that?
Oh yeah.
Yeah. All right. Thank you. Yeah,
Perfect.
that was the first thing I had to do once I had rainbow. Rainbow sparkles.
Yeah, so from there, I'm just going to take d equals VF squared minus VI squared. And then,
We're missing something.
oh yeah, over 2.
2A.
Yeah. And then you can just plug in this to where the VF was.
Okay.
So I did d equals AT plus VI, and then that would be squared, right?
Yeah. Okay, this is good because I can imagine the VI squared's going away. You know what I'm saying? So like when we square that thing out.
Doing this thing out?
Yeah, like square
Yeah.
it. Let's square it out. Let's square it out.
AT plus what?
Here, I'm gonna get
Oh,
you a little more room. Hang on a minute. So this is AT. The V got killed just because of some, stupid thing. Yeah, I think this was a VI squared. So
Yeah.
let's square that thing out. Can you square that thing out?
That'd be that'd be like AT plus VI times AT plus.
Yes.
Yeah.
Yeah.
So,
over 2a.
Yep.
Okay, so now we have to multiply out those,
Yeah, so
those
that
two binomials.
should be AT squared.
Yep. The a is also squared.
Oh yeah.
Yeah, a squared t squared.
Is this plus VI? Yeah, so
Yeah.
plus VI squared
Yeah. Now the middle term.
plus. Would that be?
2vi.
Wait, what is it?
2vi. There
Okay.
you go. Okay, now keep adding the other stuff so you've got a minus vi squared.
Oh yeah.
And then all over
2a.
Wow. Wow, way to hang in there. Way to hang in there. Okay, so what can we do at this point?
You can cancel this.
Yeah, yep, we can cancel out that. And then we've got some A's to kill.
And a T. No, we did
Yeah, so let's
top.
once you rewrite what we've got clean, and then you can keep going.
Okay, I'm just gonna take it all over here.
Absolutely.
Wait, this is equal to VI?
Plus.
2VIAT.
Yeah.
All right. So
You could take the A out, right?
So let's do a first term. So if we do the division out, so it would be D equal to, what is a squared t squared over 2a? AT squared over 2. And now we're going to add to that 2VIAT divided by 2a. Yeah, 2.
Okay. I can get rid of this too, right?
Yeah, you can get that. Yeah, use that word. There you go.
Why isn't it?
Wow, I don't know. Just scribble. You know,
Okay.
just take the black thing and scribble. Right?
Alright.
That's what we did with crayons.
So it's just VIT, right?
Yeah. Yes. Yes. That is a kinematics equation.
Alright, should I
Has
write
what missing?
VF?
Yeah. Sweet. Well done. Well done. Now we're going to go over, where's our place of... Yeah, that was the unicorn, because he started writing with like Sparkle Rainbow, and I was like, you have to have a unicorn if you're going to write with Sparkle Rainbow crayon. Shannon, I'll be with you in a second. I have very limited brain. And I move this down here. Can you move, please? Move. No. Please move. No. Sorry, Brody, I'm going to kill your art. I apologize. It was beautiful while it lasted. So, there's some other things here. Okay. Come down here. Oh, for Pete's sake. All right. So now we have another equation, and it is D equals, and it's traditionally written like this. I'm just reversing your two terms just because of tradition. Sometimes this is written with the 2 out front as 1/2. Actually, I'm going to write it that way because I think that's more commonly seen. It is exactly the same thing. I'm sure you all have the algebraic sophistication to handle that. but I'm just gonna write it this way because I think it's often commonly written as 1/2 a t squared, and I'm gonna editorialize over here and say this has no v final. Tiernan, you were going to say something.
I was, and now I'm rethinking what I was
Okay,
going to say.
yeah, take your time. While Tiernan is thinking, I want to point something out. So the approach that everybody has been taking has been this like heavy algebra, like take these two things and mash them together and smush them around. I want to point out something that we could get here in a slightly different way. So this is the top triangle plus lower rectangle. So I'm going to say D is equal to, rectangle plus triangle. This is probably not how your math teacher says equations are supposed to be written. And I apologize in advance for any trauma this causes. What's the rectangle?
VI times T.
Yeah, so D is equal to VI times T. Now this is a little messier. What's this? We gotta go base times height and a half. So we gotta half the base. What's the base? Time. And what's the height? Yeah, this is VF minus VI. But we've seen VF minus VI somewhere before. Right? Where have we seen it? We've seen it in A equals VF minus VI over T. So what is V? You have a problem? Anyway, at least I haven't sworn at it yet. I'm proud of that. I really am. Especially since we're recording this. Sometime when there isn't a camera running, I'll tell you a story of a misadventure in remote teaching early on with the camera running. So instead of VF, we go like, oh, that's AT. So right here, I'm going to go AT. What is 1/2 times T times A times T? 1/2 AT squared. D equals V initial times time plus 1/2 AT squared. But wait, there's more. So here's one, right? This is the one we just did. We just did this. But once we see this in terms of these shapes, we can do that. We could say, oh wait. So D is going to be equal to big rectangle minus top triangle. Yeah.
We had both of these written down in our notes from last.
So what's the big? So D is equal to what's the big rectangle?
VF times T.
Yeah, V final times T. And here's the sneaky thing: that top triangle and this top triangle, they're the same thing. Minus 1/2 AT squared. Boom. So our last kinematics equation, and this one's not actually in the book. They charge you all this money for that book, and they leave out a kinematics equation. I was shocked, I tell you, when I saw that. I guess they thought you could do perfectly well without it. So in the last one would be D equals V final times time minus 1/2 AT squared, and we would editorialize that this one contains absolutely no additives, GMOs, or initial velocities. So here are our 5 kinematics equations, or as my friend Christine would call them, our kinematics friends. And And I like, it's easy to joke around by like, they're friends, but I really, like, we are going to use these so much this year that if you look at them and they seem a little unfriendly to you, part of your job in this next little stretch is to start feeling like they're your friends, like just getting used to these. I know I can export the video of all of these things, so that if you're like, oh, there's a thing I forgot to get in my notes, you'll be able to get it. I think I may also be able to export this whole big thing as a PDF. So I'll try to do
We
that.
saw it on the.
Yeah, there's a little like push here for PDF, so I think we should be able to do that. How are we doing on time? Do we end at 5 past or 10 past? I keep forgetting.
10 past.
10 past? Okay. So here, I would like to just. What just happened? Undo. Whatever you just did, undo it. So these are. This is where the goods are. Five kinematics equations. And what we are going to be doing over the next little stretch is, I would say the bulk of chapter 2 in your book is devoted to learning ways of using these things and getting used to them. I want to point out, this is that we need to just highlight this crucial assumption here. This right here is a straight line, and that was really important to every single one of these equations. What does it mean if that's a straight line?
Slope is constant.
Slope is constant. What is the meaning of the slope? The acceleration. These 5 equations only work over periods of time during which the acceleration is constant. So we would say that in the jargon, we say, assuming uniform acceleration. And in the fanciest terms possible, these equations are typically known as the kinematics of uniform acceleration. And mostly we'll concern ourselves with uniform acceleration, although next week, briefly, I want to sort of, we will definitely do things that don't have uniform acceleration. We'll have to figure out ways of using these tools to beat up those problems. And I also want to talk about, last class I mentioned how important calculus is, and I want to talk about how these connect to ideas in calculus. So, okay, in our final 5 minutes, whoa, what just happened? Stop that. So, in our final 5 minutes, we find new space, go to the left, go to the left. Well, now it's feeling infinite all of a sudden. Earlier it was like, I don't feel infinite. Now it's like, yes, oh, I will be infinite. Very moody. Okay. Oh, for Pete's sake. Okay. I want to talk about problem-solving technique. I'm sure we can do this in 4 minutes. I'm going to say something in advance. We don't know each other that well yet. But I think it's a fair assumption that most people studying physics fall into, like, there's always messy, but it's like, here are categories of people, how they approach problems. Category number 1. Please tell me what is the method for attacking, like, what is the instruction set I should use when I attack any problem? And I will go through those steps and I will get to a solution. That's a category of person. Another category of person is like, I usually just kind of look at it and then I kind of see like, oh, I should probably be doing this. And then like, I write down some intermediate things. If you are in category 2, the like, yeah, I just kind of get it. I understand you. I like that's actually kind of like that's me in 10th grade physics is like, well, it ought to be like this, and so I'm like, you know, and I probably end up with the right answer. I'm not saying it's a bad way to approach things. You do have to know, like, what is the standard routine, especially for when you get stuck on something that is hard. So I will sometimes ask you, like most of the time, it's like, go solve this problem, use whatever technique you want. If you go solve a problem and you're like, I don't know how to do this, but you haven't tried the, like, here's the standard approach, I'm going to basically say, like, go try the standard approach. Here's the standard approach. Thing number 1. Identify the known quantities. So you read through a problem. The one thing that is sneaky that will be hiding out there, like keep an eye out for the word rest. If you see the word rest, that is code. They're trying to be sneaky. It means velocity equals 0. So it's like the thing does this thing and comes to rest. That means final velocity 0. A thing begins at rest. That means initial velocity 0. So you identify the known quantities, and I strongly encourage, at least at the beginning, that you just make yourself this little chart every single time, and you go like, oh, do I know the displacement? Do I know the time? Do I know the acceleration? Do I know the initial velocity? Do I know the final velocity? You just make yourself a little table. You sit down, you look at the problem, you draw this little table, and then you say, like, what are the things in the problem that I know? And you just write them in there. Then you might be like, oh, what am I looking for? I'm looking for VI or whatever. So let's say you're like, oh, I know this thing, and I know this thing, and I know this thing, and I'm supposed to be finding this thing. At this point, you should be saying, so what tool can I use? And one thing that is really good to look for is something you don't know. What do I not know? Oh, I don't know time. What's an equation I can use that doesn't have time? I'm not going to try to scan back because I'll screw up the technology. But an equation that doesn't have time in it is, equation that doesn't have time in it is like d equals v final squared minus v initial squared over 2a. So step 1, step 2, pick equation. I'm sorry this is so messy, I'm rushing. And again, I apologize in advance if this seems really tedious to you. I really want you to do this at the beginning, even if it seems tedious. I want you to write this whole equation out. I don't want you to be like, oh, I'm going to use that one, and then go through. I want you to write it down. Write it down. And if you're like, obviously I would write it down, just take it from me. There are lots of people who don't obviously write it down. So I want you to write it down. It's very important. One of the reasons to do this is that if somebody else is reading your solutions, they know what you are thinking. When you write this, you're writing, hey, I just interpreted a problem. When you write this, you're writing, here is some physics. And then 3, put in numbers. So the next thing you do is you would rewrite this with numbers in it. Okay, that is lesson number 1. We're going to do a lot more, but that is lesson number 1 in problem-solving approach. I will put this on Schoology, but essentially what I would like you to do before the next class is spend about an hour trying to make progress with problems. Great work today. You folks did really, really good work today. All right, now, oh no, have we stopped recording? Maybe we're still recording.